Thank you for your introduction. I will start with my presentation. It is, I will do it very fast. I hope the rest is in a paper which is going to be published, which has already been submitted. Well, the starting point is that several speakers have introduced the idea of the exponential growth of data flows we have to handle in all over the world, and also locally and in-house. And I have looked very careful at the in-house and in-office demand side, not what the suppliers think. Most people I talked to in the industry said, well, there's a consolidation in using Ethernet and Wi-Fi, so we are very happy with that and it's fantastic. I think no, we have to look forward, because from the wide area networks we now get from the telecom operators and the network suppliers, we will get 1 to 10 gigabits connections to our premises. And it's a little bit silly that if we have Wi-Fi with 10 or 20 megabits per second, it's the enormous bottleneck. So it can be fast in your perception, but soon enough you will have a laptop with one of these very new CPU chips from, for instance, Apple or Intel, who are so powerful that they are demanding more speed. The speed there's demand for more speed. So please, the next, go to figure 8, the number 8, please. Yes, this one. As you can see depicted, within premises, there is mobile access. You can get 4G or 5G in-house. You have new generations of Wi-Fi, like Wi-Fi 6 and 6E, and you have Bluetooth, but there's a certain boundary at 1 gigabit per second where they are not capable of increasing speed. If you need higher speeds, you need more power or connectivity, or it will congest because you need there's more radiation, there's more interference, your neighbors will receive the signals, etc. also. So with radio frequencies there's a kind of bottleneck, and let's see if optical can solve that bottleneck. Again, radio is fantastic, but above 1 gigabit per second, radio is not penetrating walls very well. So you have to increase power or have mesh networks, but that's, well, we run into a kind of brick wall with radio connections, and also the spectrum below 1 gigahertz is crowded, and it is well, everybody tries to use higher frequencies, radio frequencies, but that is not sufficient. So okay, go to picture number 11, please. Yeah. No, this is not 11. This is the next one, please. Yes, this one. If you carefully look at what is inside the laptops and mobile phones and tablets, there are these very powerful chips who are connected to a bus, and the bus handles the contention between these blocks. If you move outwards towards Ethernet, the Ethernet handles the contention, And if you move outside of your premises, you will have wide area networks with level 2 and level 3 switches who handle contention. This is actually what is driving the bandwidth demand. In my lifetime as an engineer, I graduated in Delft, and then we had 110 bits per second teletypes. Now it is about 100 million times faster, that 10 gigabits or 100 gigabits is, and still the processors are the clients of our networks, not the people, not the devices. The CPUs are demanding to have response. If they send a page you want to look at, it keeps trying to get a response. If you have a World Wide Web page, you have about 10 or 20 or 30 little applications which are trying to get answers, and that is what pushing this industry, the CPUs. We have to bow to them and connect our networks. Yeah. Okay. Well, the next picture is what the wireless optical communication people have been trying to. So please go to the next page. Yes, this is a vertical organization. My problem is that it will not scale very well. It is, yeah, is it bidirectional? It is still in a lot of, well, also the beam steering is very interesting, but we have to design a kind of architecture in which this can be functioning. And that my proposal is to turn it half from vertical to horizontal, and that is what is the next number 14, please. Go. Yes. The next one. Yes, this one. This is my proposed architecture. I propose that we use plastic optic fiber inside the buildings or offices to connect each room with one bidirectional link. You can use very easily the fiber optic cables. Okay, here. In the tubes which are there for the volt 230 volt alternating current. So these tubes are already in the building, and you can very easily, even the consumers themselves, can install these plastic optic fibers. And then you so you have, if you introduce wireless optical communication, you are sure that it is not going through walls. So you have to use plastic optic fibers to go through the walls. And if each room you have one or more devices on the wall, and you can install inside the room a number of what I call Wi-Fi devices connected to laptops or tablets with USB-C. Then you can build a Wi-Fi mesh network inside the room. One of the important things to know is that 80% of all mobile communication is nomadic. It means that you sit stationary at the table or in a library for a few hours and then go home, sit stationary, or go to a company, sit stationary. So it is not, this is not built for mobile while you move, but when you sit down somewhere in a room, you don't have to have all these overhead for data communication protocols like handover and all kinds of other things. You can, it is a limited number of places in each room which are viable for sitting down and connecting, and that is very easy to do with the Wi-Fi mesh, which can be, so the optical wireless communication part of this is making these mesh connections, and that is basically what I propose. And so all these things are already available. The wireless, the plastic optic fiber stuff is you can buy the infrared beams from the wall to these Wi-Fi things, and also the USB-C. Another thing which had to be solved, which is a bottleneck, is power for the laptops, power for the devices for connecting. And it is a good coincidence that the plastic optic fiber is in the same tube as the power cables. So you end up with power at the here in at the wall, and the Wi-Fi's and the laptops can also power each other through the USB-C cable, which is also for not only for signals but also for cables. Now, what does it look like? And please show the next one. Yes, it can be like instead of having something from the ceiling, you have a thing on your table with a number of these devices which make a mesh. Or the next thing, so dit is Philips lichtspreiding eigenlijk. The next one is, is that you build it into a stick, which is, the key is that the wireless, the optical mesh is above your head. It can be done with infrared optic links, and so this can all be built and combined into units which can be delivered by Apple or Huawei or whoever is in. If you concentrate on the hundreds of millions of people with mobile devices, like students and other young people who sit down in lecture halls or whatever, then it's not a niche. It is really a very big consumer market for hundreds of millions of people to use. So I think it is interesting to start experimenting with such a setup, and this is what I have thought of as an architecture which is feasible, and I look forward to talk to companies who want to start building prototypes and test it. And also the mesh protocol is already available in various forms for mobile phones, and I think this is the next step after Ethernet and Wi-Fi, and it is no, it may be take off or in other ways or combined with other techniques which have been displayed today. That I hope that it will be a success. Thank you very much. That's all.